Okay, I've been asked to help work number 8 on your Chapter 18 homework from several students, so I'm going to go ahead and give you an example of this. It's just a multiple step process, and just kind of break it down, and it'll probably be a lot easier for you. So here we have the recommended dosage of gentamicin for a child is 6 milligrams per kilogram per day in 2 equal doses. So then we're ultimately going to divide that by 2. The child's weight is 44 pounds. The tubing drop factor is 60 drops per milliliter, and the medication is supplied 60 milligrams in 100 milliliters to infuse over 90 minutes. Alright, so first off, we want to do the A, weight in kilogram. So we take our pounds here and divide that by 2.2. And that gives us 20 kilograms. Then we're going to plug in this kilograms here. So we're going to multiply 6 by 20 to give us milligrams per day. So I'm going to do 6 times 20. It gives us 120 milligrams per day. However, we want it in per dose, so we want to divide this number by 2. So that gives us 60 milligrams per dose. So our child's weight in kilograms here is 20. Calculate the dose for this child, 60 milligrams per dose. And then we want to calculate the rate in milliliters per hour. So I'm going to put this down here. Whoops. I didn't mean to put hour there. So again, we're going to solve for milliliters per hour. So the first step of this, now since we already done this, go ahead and we can scratch this out. We can scratch this out, this out, and this out, which leaves us our per dose. So in milliliters per hour, we're going to not use our 60 drops per milliliter on this one because that's going to go with our drops per minute. But we are going to use this 100 milliliters. So I want to put 100 milliliters over 90 minutes because that goes together here. And I don't want to end with minutes, I need hours. So I'm going to do 60 minutes is equivalent to 1 hour. So then our minutes would cancel out. So we would have 100 times 60, which is 6,000, divided by 90, which gives us 66.6 remaining. So I would round that to 67 milliliters per hour. So now we've used this information, and that goes here, 67 milliliters per hour. So now we want to calculate the drops per minute. So with dimensional analysis, since we're solving for drops, I want to start out with drops on top. So of our other information here, we have 60 drops within 1 milliliter. And since this is milliliters, we have to do milliliters here. So with this one, I'm going to put 100 milliliters again over 90 minutes. And since we're solving for drops per minute, and that's in minutes, we stop there. So again, we're going to do 60 times 100 divided by 90, which as you'll see up here is the same. So it's going to be 67 drops per minute. So I hope that helps. And if it doesn't, just let me know.